Hey there. So, when you look at a graph like a stock chart going up and down, or even just the path of a ball thrown through the air, your eyes kind of just lock on to the highest and lowest points, right? The peaks and the valleys. But how do you find those exact spots using math? Well, that's exactly what we're going to dig into today, finding what are called the extreme values of a function.
Yeah, it's pretty easy to spot a peak or a valley with your eyes, but pinpointing its exact location, that's the real challenge. And that is the big question we're going to tackle. Think of it like we're going on a mathematical hunt for these super important points. And here's the cool part. There isn't just one way to do this. We're actually going to look at 3 totally different ways to solve this problem. We've got a method that uses words, one that's all about following steps, and a third one that's super visual, all about shapes. The whole idea here is for you to find the one that just clicks, the one that makes you go, aha, okay, that makes sense. All right, let's jump right in with method number 1, which I'm calling the words. This one's for you if you're the kind of person who likes to get the definitions straight first, before we even touch the numbers.
So, the big term for today is extreme value. It sounds kind of fancy, but really, it's just the formal name for the absolute highest or lowest point on a curve. Seriously, just picture the very top of a mountain, or the deepest part of a canyon. That's it. That's an extreme value.
And this idea breaks down into 2 super simple parts. You've got a max, short for maximum, that's your peak, and you've got a min, short for minimum, that's your valley. Max and min. See? Simple.
Okay, so maybe definitions aren't your thing. If you're thinking, just give me a clear recipe to follow, well, this next method is tailor-made for you. Let's get into method 2, the steps.
So here we go, a 5-step process that is pretty much foolproof. First, you've got your function. Second, you find its derivative. Now, if you're a bit rusty, just think of the derivative as a tool that tells you the steepness or the slope of the curve at any point. But here's the absolute key. Step 3, you set that derivative to 0. Why 0? Well, think about it. At the very top of a peak or the very bottom of a valley, for just a split second, the curve is totally flat, right? Its slope is 0. That's the secret. Then we just solve the equation to find the exact x where that happens.
Okay, theory's great, but let's actually try this out. We're going to use the function f of x equals x squared minus 6x. Our mission is to find the x value for its peak or valley.
All right, step 2, find the derivative. For our function, the derivative, which we write as f prime of x, is 2x minus 6. So, this little formula here can now tell us the slope of our original curve anywhere we want.
Now for the magic. We take that derivative, 2x minus 6, and we set it equal to 0. This is where it all comes together. We're literally asking the math, hey, at what x value is the slope of our curve perfectly flat? And solving this little equation is going to give us the exact answer.
And when you do the math, you get x equals 3. Yep, just add 6 to both sides, divide by 2, and boom. At x equals 3, the slope is 0. That's the spot. That's our magic number.
And now for the final step, number 5. What does this actually mean? It means all that work just told us that for our curve, x squared minus 6x, its extreme point, which happens to be a valley in this case, is located precisely where x equals 3. Done.
But what if you're not a fan of words or steps? What if you're more of a visual person? Well, if you learn best by just seeing things, then our third method, the shapes, is going to be right up your alley.
This one is just wonderfully simple. All you have to do is look at the shape of the curve, which is called a parabola. If it opens upwards, kind of like a smile, then you know it has to have a low point, a minimum. But if it opens downwards, like a frown, then it has to have a high point, a maximum. It's like an instant visual shortcut.
Okay, so we've covered words, steps, and shapes. 3 totally different ways to get to the exact same answer. Now it's your turn. Time to try it out and see which of these methods really feels right for you.
So here are 3 new problems for you. The challenge is simple. Find the location of the extreme value for each one. Go ahead and pause here and give them a shot. Use whatever method you want, the words, the steps, the shapes, whatever feels best.
And that really gets to the core of what we're doing here. This isn't just about crunching numbers to get an answer. It's about finding a way to understand the process that makes sense to you. Because, let's face it, learning is not one size fits all.
So, I'll leave you with this to think about. Which method felt the best for you? Was it the words, the steps, or the shapes? Honestly, just figuring that out is a huge win. Thanks so much for tuning in.